inverse variation. So before we talk about inverse variation, let's review direct variation. So direct variation should have been done in your Algebra 1 class. So for direct variation, the equation is y equals kx, where we call k the constant of variation. Essentially, for direct variation, k is your slope. So when we say that variables vary directly, we know that these variables will follow each other in size. So if one variable gets larger, so does the other, and vice versa. If one gets smaller, so does the other. So these are all examples of graphical direct variation. And so if you notice, every one of these lines goes through the origin. So with direct variation, it is a linear function that goes through the origin, which is why you did it back in Algebra 1. What we're talking about in Algebra 2 is we're going to talk about inverse variation or indirect variation. This is Algebra 2. And so for inverse variation, notice the difference in the equation. Y is equal to k over x. And obviously k can't be 0, because if you make k a 0, you will have just plain old y equals 0. We still call k the constant of variation. But since it is inverse, when we say that two variables vary inversely, they go in opposite directions. Opposite meaning inverse. So if one gets bigger, the other gets smaller, and vice versa. If one gets smaller, the other gets bigger. So here are a few examples of equations and graphs of what we call inverse variation. So the most basic is y equals 1 over x, and this is actually called a rational function. These are all rational functions. Okay? Rational just means a fraction and the x is in the denominator. That's what creates a rational function, is having the x being in the denominator. So we're going to decide if each of these equations represents direct variation or indirect variation, which is also called inverse. Now, the easiest way to do this is solving for y. If you get y by itself and come up with y equals a number over x, then it's inverse variation. If you solve for y and you get y equals a number times x, then that is direct variation. If you get something that doesn't look like either one of these forms, then it is neither direct variation or inverse variation. So let's look at number 1. If we solve this for y, that means we're going to have to divide out x. So we would end up with y equals 5 over x. Well, since x is in the denominator, this is a rational function, which means this is in fact inverse variation. Number 2 already has y alone. But I see that we have x minus a number. Well, neither of these forms up at the top talk about a plus or a minus. It's either multiply or divide. And so since this is in neither of those forms, this is not inverse and it's not direct variation. It's neither of them. Let's look at number 3. So to get y by itself, we have y divided by 2. So to undo the division, we're going to have to multiply both sides by 2. And we end up with y equals 2x. Well, 2x is a linear function, and that is in the form of y equals kx. So this is a direct variation. Now, classifying data as either inverse or direct variation. So again, here's the general equations, y equals kx and y equals k over x. We need to find that constant of variation. That's the definition of inverse or direct variation. So for direct variation, k is going to be the division of y over x being a constant number. For inverse variation, k equals x times y will be a constant. Basically, where that comes from is, let's think, if I take this and I solve it for k, I'm going to have to multiply both sides by x to undo the division on the inverse function. And that's why the multiplication is on the inverse. For direct variation, if I want to solve this for k, I'm going to have to divide out the x. So that's why the constant of variation is backwards from their function. So we're going to take each table and decide if either of these give us a positive or a constant number. Multiplying is easier than dividing. So what I usually like to check first is I like to check for inverse. So for inverse variation, we know that x times y is constant. Every time you multiply x and y, you get the same number. So let's just start with the first two. So 2 times negative 12 is negative 24. Now let's try the other one. 4 times negative 6 is still negative 24. So far we have a constant number. And then let's try 6 times negative 4. Well, that's still negative 24, so we're still good. And 8 times negative 3 is still negative 24. So because we had the same number throughout, all of the x's and y's being multiplied together, that means this is in fact inverse variation. If we had a different number along the way, then it would not have been an inverse variation. So let's look at number 2. Again, I think multiplication is easier than division, so let's start again with inverse. And so that means x, y will be constant. So we're going to start with the first x and the first y. So 1 times 2 is 2. So let's do the second x and y. 2 times 4 is 8. Well, that's already not the same number. So that means that this is definitely not inverse variation. So now let's try direct variation. So for direct variation, y over x is constant. And make sure you do the y in the numerator, y over x. So for the first pair, 2 over 1 is 2. Second pairs of x and y, 4 over 2 is also 2. So far we have the same number. Then we try 8 over 3, which is just 8 over 3. You can't simplify that. But I do know that 8 over 3 is different from 2. So we have lost our constant. So this is not constant either. Well, since it's not inverse variation and it's not direct variation, well, that means the answer has to be the fact that this is a neither. This is just a function. It's a random function. And let's try the third one. So again, inverse. X times y must be constant. If that doesn't work, if that doesn't give us a constant number, then we try direct, which is where y over x has to be constant. So I want you to pause the video and try to determine if this third table is inverse, direct, or neither. And you should have come up with direct variation. Now let's actually work closer with inverse. So because direct variation is something you should have learned in Algebra 1, we're going to spend the majority of the time focusing on inverse variation. So how do we actually use inverse variation? So here's an example. It says the variables x and y vary inversely. So that's your first clue that this is inverse variation. And y is equal to 4 when x is equal to 3. So it has two parts to this problem. The first part says write an equation that relates x and y. The second part of the problem says then determine the value of y when x is equal to negative 2. So the first thing we're going to do is write the equation that relates x and y. So that's this first step. So the inverse variation layout is y equals k over x. What they've done is they've given you what happens with two variables. If y is 4, that means x is 3. Those two are related. Those two state, it's like a coordinate point, 3, 4. So what we have in our equation is we have y, we have x. We're missing that constant of variation here. So what I'm going to do is I'm going to substitute the numbers that I actually know. When y is 4, x is equal to 3, and I need to figure out what the heck k is. So we're going to solve this for k. So the way we solve this for k is we're going to multiply both sides by 3, and we get k is equal to 12. Now that we know the constant of variation, we now can find the equation. I know the equation will be y equals 12 divided by x. So what you've done is you've taken a very specific example and we were able to create a general equation. So this equation will work for this pattern for any value of x and y, which is where the second part comes in. So part number 2 asked you to find Determine the value of y when x is equal to -2. So now it only gives you part of the pattern. I don't know y, but I know that x is going to be a -2. So what we're going to do is we're going to use this equation we did in part 1, and we're going to substitute to find the value of y. So y will equal 12 over, and it tells us that x is equal to -2. And if we solve this for y, we will come up with, well, 12 divided by -2 is -6. So when x is equal to -2, y is equal to -6 if it follows this pattern. I want you to pause the video and see if you can try to at least write the equation for number 1, or for part 1 on number 2. And here's your equation for the first part of number 2. If y varies inversely, that means you're going to use k over x, and y is 2 when x is 5, y is 2, x is 5, solve it for k, and we get k is equal to 10. So the general equation for this pattern is y equals 10 over x. Now the second part can get kind of tricky because of that fraction. So what is the value of x when y is equal to 5 over 2? So y is a fraction, so this y is really 5 over 2, equal to 10 over x. This should hopefully look familiar. This is a proportion. So we need to find x. Well, the problem is x is sitting in the denominator right now. So what you guys have learned in the past is cross multiplication. When you have a single fraction equal to a single fraction, you solve this by doing cross multiplication. 5 times x will give you 5x is equal to 2 times 10, which will give you 20. And then to simply solve for x, you're going to divide out the 5. So x is equal to 4. So when y is 5 halves, your x is equal to 4. Now, this is the basic process you're going to use in order to solve application problems involving inverse variation, like 3 and 4. So for number 3, the time t in hours that it takes a group of volunteers to build a playground varies inversely with the number n of volunteers. It takes a group of 10 volunteers 8 hours to build the playground. Anytime you have a real-world situation, defining your variables is key. What is the x and what is the y? Which one is x and y depends on how the problem is written. So it says volunteers to build a playground varies inversely with the number of volunteers. So the time t varies inversely with the number of volunteers. So what that means is it always written in y varies with x. Y varies with x. And this is even the case for direct variation as well. So because it says the time t in hours comes before the varies inversely, that means that time is actually your y. Then it says varies inversely with number of volunteers, n, that's your x. So n is really x, which is the volunteers. So this is something that's important to remember. It always is y varies with x. The item that comes before the words varies inversely is the y variable. The item that comes after is the x variable. So let's go ahead and set this up then. So I know that it says varies inversely. So I know that it's going to be y equals k over x. Okay, so let's see. It says it takes a group of 10 volunteers 8 hours to build the playground. So let's see, 10 volunteers, so x is equal to 10 when y is equal to 8. 10 volunteers will take 8 hours to build the playground. Okay, so let's plug those in. Y is equal to 8, k over x is equal to 10. And we need to figure out that constant of variation. So we're going to solve this for k by multiplying both sides by 10, and you end up with k is equal to 80. So for letter A, write an equation that could be used to determine the number of hours it would take any volunteers to build the playground. We have the equation, y is equal to k of 80 over x. So here is the equation that models this situation. Now letter B says, how many hours will it take 45 volunteers to build the playground? So now that we have the equation, I can figure out the time. So 45 volunteers, well, that's X. So Y will be 80 over 45. And we're going to simplify. So 80 divided by 45 is about 1.78. And a decimal makes sense for this because we're talking about time. So your answer will be, it will take 45 volunteers, 1.78 hours to build the playground. So 1.78 hours is the correct answer for this. Takes two parts. Set up the equation and then figure out the answer to the prediction. Now let's look at example 4. To balance the board in the diagram, the distance x in feet of each animal from the center of the board must vary inversely with the animal's weight y in pounds. What is the distance of each animal from the fulcrum? So luckily in this case, it gives us x and y. So we don't have to use this to figure it out. X is the distance from each animal from the center, which is called the fulcrum. That's what that is. So X is distance from center, not from each other, distance from center. And Y is the weight of the animal. So what this question is really only one. It says, what is the distance of each animal from the fulcrum? So basically, how far away is the cat and how far away is the dog from the center of this board? So the first thing we need to do is find K for the cat. And we're going to use the fact that we know that x and y vary inversely, so we are going to use y equals k over x. Well, the y has to be the weight of the cat. And so in this case, the weight of the cat is 7. So 7 equals, I don't know what k is, over, and x is the distance the animal is from the center. Well, unfortunately, I don't really know that either, because that's the question. But I do know that the distance the cat is from the center is d. I know that. So I'm going to replace x with d and see what comes up. So let's go ahead and solve this for k. So I'm going to multiply both sides by d. And we get k is equal to 7d. So we're going to hold on to that for a minute. Now let's do the same process. Let's find k for the dog. Let's see what we come up with on this one. Well, we still know that y and x vary inversely, so it's still k over x. I know that the dog is 14 pounds, so 14 equals k over. Now the question is, how far from the center is the dog? Well, if from the cat to the dog is 6 feet, I really only need this piece right here. That's really all I need. So how do I write that little portion as an expression? Well, if the whole thing is 6 feet, I need to take away this distance that the cat is. I don't want this part of the distance. All I want is this piece here. So that piece here is actually the whole distance between the cat and the dog minus the distance the cat is away, because this is the part that I don't really care about right now. I just want to know how far is the dog from the center, not how far is the dog from the cat. So I need to do 6 minus d. So for the dog's case, the x value is actually 6 minus d. And so again, we're going to solve this for k. Now, because there's more than one thing in the denominator, there's a invisible set of parentheses. So when we multiply, we're multiplying with parentheses on this 6 minus d. Well, those are going to simplify on the right, and we have 14 times 6 is 84. 14 times negative d is negative 14. So for the dog, the k is equal to 84 minus 14d. Now, these should be the same values. If there's a k and a k, step 3 is we're going to find the distance, find d by setting K equal to K. If this is a K and this is a K, then that means 7D has to be equal to 84 minus 14D because they're both equal to the same variable. K in one place is not different than K in another place. So now what we have is we have 7D equal to 84 minus 14D. And we're going to solve this for D. So we're going to add 14D to both sides. And so we get 21D is equal to 84. Divide by 21, and we find that D is equal to 4. Now, that may or may not be the answer to my actual question. So let's review what the question actually asked in the first place. The question asked, what is the distance of each animal from the fulcrum, from the middle? Well, the cat was easy. The cat is just D feet away. So if D is equal to 4, that means the cat is 4 feet away from the center. The dog, however, is a little bit more complicated because we found that the dog was 6 minus D away from the center. So if D is 4, that means 6 minus 4 would mean the dog is 2 feet away from the center.